Hello and welcome to Partially Redacted, a podcast where we discuss privacy and security engineering and related topics. I'm your host, Sean Faulkner, and today I'm joined by Roshmik Saha, head of engineering at Skyflow, and we'll be talking about what it takes to build your own data privacy solution. Roshmik, welcome to the show.
Thanks, Sean. Thanks for having me on the show.
Awesome. Yeah, thanks for being here. I'll actually be seeing you in person very soon in India. So this is a little warm up session for the week we're about to spend together. But for the benefit of the audience, let's have you start with an introduction. Who are you? What do you do? What's your sort of work history? And how did you end up where you are today?
Yeah, so I grew up in India. I did my undergrads here. I actually have an undergrads in mining engineering, and then I have a PhD in aerospace. So I don't know how that happened, uh, but my PhD was in robotics, which is to do with like simultaneous localization and mapping. The truth is that I have been coding since somewhere in middle school, and I have always enjoyed that, and it made sense to me. And I have always built platforms in my real life and a lot of performance engineering. Um, I did work for Lyft self-driving, which was fun, which was related to my PhD. I think it is one of the coolest projects I've worked on. And I also spent a number of years at Microsoft building various parts of the Windows or Bing ads. How I landed up here. So I always, nobody told me when I was young that I should start with a startup, but I probably started with the biggest company you can think about, Microsoft. And I always wanted to do a startup, work for a startup, but more so, uh, I love the people. The people I trusted the people whom I started the company with, and specifically Anshu. And then on the other side, the problem made sense. Everybody had a issue with data privacy. Everybody was paying a lot of money. It made business sense and engineering sense at the same time. So it was an easy choice. So
Yeah, it's great. So the it sounds like you always had the desire to do a startup, and that's what led you to co-founding Skyflow. I should have actually add that into your introduction besides just your title, but this background you had from doing a PhD in aerospace and then working on self-driving cars at Lyft, has any of those kind of skills been transferable to the work that you're now doing in the data privacy space?
yes, I think one of the top things is performance. So in self-driving, performance was critical. We were trying to build real-time systems. In the real time means very different outside of robotics. So we are still dealing with real time data, but it's just not millisecond for everything for an interrupt. That's the biggest one. Secondly, self-driving car can impact life, right? So you have to be correct. And if you translate that to security, anywhere you are incorrect is a bug. It can, the worst case being a security bug. So I think those two aspects are very important, which I have experienced in both robotics and some of my PhD work before. So,
Yeah, there's a very high cost to being wrong when it comes to something like self-driving car, robotics, and now in the privacy and security space where people are essentially trusting that the platform they're buying into is doing the job that as advertised, essentially, right? All right, so we're going to be talking about kind of what it takes to actually build your own data privacy solution in terms of engineering costs, the components to think through, maybe the maintenance costs. And let's say that I told you I was starting a new company, let's say in like the business to consumer space. So I'm going to have things like account data, user data to pay for transactions. Internally, I'll have teams from like marketing, sales, customer support touching all this data. And I tell you, I'm going to engineer my own solution for protection and governance of data. What would your response be to me as my friend?
I would say good luck with it. So no, I'm just joking, but it's only half a joke. So it takes a whole lot to build the solution right. And actually, let me take a step back. Uh, to build a proper data privacy solution, I believe isolation is critical. And if you are building it yourself, you will never attain full isolation. So that's one thing is very hard to achieve when you're building it yourself. Other than that, I'll say that there are just so many aspects to it, right? Why would you take that uh, opportunity cost? Like, is building a like something like a data privacy vault your uh, core business? If it is not, it doesn't make sense to invest in like building infrastructure for it, building encryption, tokenization, and I think a core habit of most engineers, and I know you are an engineer, so is that we only look at the core problem, which most of the time you can figure it out in a couple of weeks or over several weeks. But we overlook the 99% of the work that actually has to go into building a product. So whatever you have in mind, I would just multiply that by 100 to have an approximate cost.
So you mentioned that it's going to be very difficult to achieve full isolation, and that isolation is like a key characteristic of a great sort of data privacy security solution. So why is isolation so important?
So, so if you think about your valuables and say your regular items, you never put them together, right? So what I normally talk about is your you never put your cheese and diamond together, right? There is no way you can manage who has access. You cannot manage how to use it. It's just too different. And the same thing happens with sensitive data and non-sensitive data. The usage patterns are different, the use cases are different, and the access is, of course, very, very different. So if you're building anything in-house, engineers will find a backdoor. So unless the data is actually or the system is managed by somebody else, full isolation in reality is impossible, I would say. I have never seen that happen. I have never worked in a place where there is zero backdoor. So
I see. So essentially, even if you're trying to achieve something like isolation, if you're building it yourself, it's very likely that it's not actually truly isolated. Someone has access to that information.
yes, and for expediency, it makes sense for a company to just say, or one dev manager making a deal with another dev manager, hey, give me access for the next 2 months and I'm going to remove it. We are going to do it the right way afterwards, but that never happens, as we all know.
Right. Yeah. There's always going to be a propensity to, cut corners when timelines are people are under pressure to hit certain targets and so forth. Then it's very easy to be like, well, we'll cut a few corners here. We'll come back and fix it. And then inevitably, what ends up happening is that tech debt never ends up being paid until you are in the news for some sort of data breach or compliance issue, essentially.
Because at the end of the day, these are all software layers, right? There is always a way to cross these logical boundaries. So unless you are isolated in terms of hardware or in terms of organization or in terms of completely different cloud providers, so there has to be a layer of isolation which you cannot choose to violate.
Right. So let's start with something maybe a little bit more constrained than the example I was talking about, where there were I'm building out some sort of B2C company. There's a lot of types of data. Let's perhaps focus on something like just credit card data. So this is something that a lot of people who've built any kind of system have ever dealt with some form of credit card data, whether it's through leveraging a third-party payment processor or building something out themselves. But if I was to build this myself in terms of handling credit card data, what do I need from an infrastructure standpoint to securely store, handle, and process that credit card data?
So I think infrastructure is the starting point. So you will start with, say, network security. How do you set up a VPC properly? You will start with how do you, what kind of a cluster you set up. You will have to do pen testing around it. You will have to follow all the best practices around the IAM policies, all the AWS settings, so to say. Each piece of uh, software that you deploy, they will have to follow all the best practices. Like in the Terraform scripts, the Helm scripts, everything has to get verified. And checked, and also upgraded every time that there is a change. So these are only the starting points in terms of infrastructure, right? And you have to make sure that you are using all the certificates the right way. You are using a valid certificate provider. You are like doing rotations at the right period. So that's just how the infrastructure starts, but that doesn't end there. So as soon as you think about encryption, you have to think about encryption keys. How do you protect your keys? Uh, how do you protect your secrets? How do you rotate them? Everybody forgets about key rotation. So that's then you are kind of done with encryption. But then you think about tokenization. What solutions do you use for tokenization? It's very easy to say something is a random token, but have bugs in it where it turns out that it is not that random actually. And when you have enough data, you can actually predict the next token that you can generate. So there is all these kind now that now then you'll have to uh, hire a encryption expert, and then uh, so and we are just starting to scratch the surface. I'm not sure how much you want to know that how many things we'll have to kind of think about.
And then a lot of these things around, making sure the servers stay up to date, making sure that you're using the right types of encryption algorithms, and you're also doing the hard work of rotating the keys properly. Are these required from a PCI DSS standpoint?
So some of them are. I think they have some standards around you cannot use deprecated versions. If there is a security uh, issue, then you have to address it within, say, sometimes it's a P0, it's like a few days. If it is a P1, P2, then you have like varying to some weeks and months. But that's not enough, right? When you're dealing with sensitive data, you have to be on top of the game. PCI compliance is kind of the lowest common denominator which everybody is able to satisfy. That doesn't mean it's the highest standard, what we should expect out of data privacy software.
Yeah. And then we were talking strictly sort of from an infrastructure cost standpoint, like what's it take to stand up the basic components to securely storing, handling credit card data. But what other types of costs would I need to think through? Going fast forwarding to beyond just standing up the infrastructure that I need to do this.
So after you, then you have to create the entire software there, right? So once you have figured out secure infrastructure, then you start building like encryption and tokenization because you want it to get handled the right way. You cannot leave plain text data around. Then you have to start thinking about, hey, how do you connect to like your third party providers, right? So you have to send plain text data to them, or can you use tokens? Um, then so that's do you use a proxy? Do you use what kind of guarantees that a proxy give you? You also have to think about like runtime. What kind of protections can you build around your runtime? So we do certain things where you can run um, logic and operations on encrypted data. So is that something that is important for that use case for credit cards? I know when you do credit cards, maybe not on day one because you are not doing a lot of operations, but in day two, you might be doing saving some kind of uh, uh, amount of money in the account, or you might have some transactional data where you want to do some sum and average of it. So yeah, things keep getting added on, and then key management is a very involved subject. It's very easy to do small errors, like you cannot cache anything. So if you keep the key in the cache, then it's as good as like plain text.
In terms of, one of the things you touched on was the idea that, especially with credit card data, you're probably going to have to pass that to a third party at some point, whether that's a payment service provider or maybe you're connecting directly to the card network. But you're going to presumably have to pass that credit card data in encrypted in transit, but you're going to have to decrypt it on your end and then pass it over. So, what are the kind of the requirements around? the this like where that happens essentially. So somewhere within whatever your solution is for handling credit cards, you're going to have to decrypt it at some point and pass it over to the third party. From a security perspective, like what are the requirements to actually do that in a safe way?
So, in terms of requirement, I think first, as you mentioned, it should be encrypted in transit. There are different providers who have slightly different requirements or implementations on how you connect with them. So some people implement encryption of data bits also. There are different certifications they use, different kind of certificates you have to provide. Then there are different kinds of handshakes that happen that you have to implement. And also, I think it will be interesting to touch upon the PCI compliance aspect of it if you are dealing with credit card data. So, very interesting point is if you never see plain text credit card data, you don't really need to invest time in PCI compliance. It becomes really simple. So, the moment you are reading and handling plain text credit card data, you will have to start thinking about PCI compliance, and which is not a cheap thing to do. It turns out it takes a lot of time and effort and money to get it done.
Hey there, Sean, host of Partially Redacted. You probably guessed that since at this point in the interview you probably recognize my voice. I've been told for years that I have a face for podcasting, but no one has mentioned whether I have a voice for podcasting, so sorry about that. Hopefully, the awesome guest makes up for it. Anyway, if you're enjoying this episode, please support the show by subscribing and telling your friends. You can also join the Partially Redacted community at skyflow.com/community. Okay, that's enough for me. Back to the show.
So, moving beyond credit card data, presumably if you're storing credit card data, you probably have additional user information that you might be storing about the customers or the users of your product. What are the types of features and technologies that I need to build to meet maybe existing privacy requirements or reduce the risk that I end up in the news for data breach when I start to extend this even beyond the handling of credit cards?
So, yeah, great question. So, I think from a compliance point of view, the requirements are kind of what we talked about. It's not that much, but if you realize that most of the data breaches have happened to companies who are compliant. They were not out of compliance, but they still got hacked and breached and um, kind of incurred a lot of customer data loss. So, one of the core principles that we follow at Skyflow is zero trust principle. So, I think that's one of the most powerful tools to avoid uh, any kind of misuse of data. So, if you take the case of, say, Equifax, where you just had somebody with access come into the system and take a data dump of everything, if that person did not really have access to the data, then uh, nothing would have happened, right? But since the database is kind of open and like once you're into the system, you have full access to the data, it there was no zero trust principle to say the least.
So I think a lot of people are familiar with the concept of zero trust from like a security network standpoint. When it comes to data, what does zero trust really mean?
When it comes to data, um, I think it means probably the same thing. So uh, every time there is you are jumping the security boundaries, you have to verify the identity, the authorization. So what it means is even when you're dealing with data, you are still dealing with a lot of services. So today, data is somewhere you don't really know exactly where the data is, right? It's somewhere in the cloud, but then that data is surrounded with a bunch of services that actually helps you access the data, that deals with the data. So as the data is passing through the system, at every point we have to uh, trust but verify, right? So what that means is the all your microservices, all the entire fabric of your deployment has to know who is the actual identity who is trying to access the data at that point. So that is what zero trust in the data world means.
All right. Yeah. So essentially, you know the identity of the person, and every time they're trying to access any information, you're not trusting that that person has access. You're verifying that they have access to that information. Is that right? Yeah. All right. So you touched on a few different things in terms of the sort of core principles of the types of things that you need to be thinking about to properly build a data privacy solution. You talked about, essentially full isolation, zero trust, as well as some of the requirements around the infrastructure that you need to set up to maintain network security, encryption key rotations, all this type of stuff. Now, what kind of engineering cost does it take to sort of build and maintain one of these? Like how many people are we talking about, and how long?
So it depends on a lot of things, the exact number of people that will be needed. If but I can start by talking about like what all the things you will have to do, right? So and what kind of people are needed. So you will need different people with different skill sets. So uh, so you need somebody with a privacy mindset to be able to implement zero trust. You need a encryption expert to build and maintain all the encryption algorithms and tokenization algorithms. And then you will need to have so if you think about privacy, uh, it means that who can access the data in what form. So what is legal access of data? What is non, what data access is not permitted. To what it means in software terms is that you have to have a very strong authentication and authorization model. And the authorization model becomes quite elaborate. So, because it involves things like redacted text, masked data, sometimes plain text only when needed. You have to define what is the requirement for each role, who can access what kind of data. So, if you add all of it, I think it will depend on the number of features that is needed. The PCI use case is in that phase a little bit simpler, but uh, the normal engineering judgment says every feature takes like 3 engineers for 2 3 months to get something to production, and the requirements keep growing, and then you almost end up needing similar or a little bit less people to maintain the project. So if I had the simple answer is like all the engineers that are in Skyflow will probably be needed at some point, but for a specific use case, it might be a little bit lower, but not a whole lot lower. And I think that's the interesting part that if uh, if it is not the core business for anyone, like why rebuild it over and over again? Right? Why not reuse where one company is focusing on all of this and building a product?
Yeah, I think that's a good question. It's something that we've talked about in the past on the show for a few different things. Like, I think that there was a time, of course, when every company built authentication, and they did that over and over again. Like every engineer built like authentication like 6 times, and then companies like Auth0 came along, and now if you're building anything essentially certainly enterprise grade, you're probably not building your own rolling your own authentication. You're leveraging one of these tools to offload that responsibility. Why do you think that companies tend to take on this data privacy security problem themselves? Maybe not for PCI. I think a lot of times companies are relying on third parties, whether that's a payment service provider or something else. They kind of understand, okay, well, I don't want to deal with PCI compliance. I'll offload that. But for some of these other data security privacy challenges just around the management of PII, it seems like a lot of companies are taking on that responsibility themselves, and feeling like they can handle it using existing database technologies and whatever else they have in their stack.
So I don't completely agree that they are doing everything that is needed to tackle the privacy problem, first of all. I think they are more looking at compliance and almost building whatever is barely needed to be in compliance. I think most companies are trying to do that. And even if we take a more purist approach, that if we assume that, yeah, companies are investing the right amount uh, is needed to satisfy or to properly protect data. Um, I think as developers, and especially it is mostly an engineering decision, right? It's an engineering problem, it's an engineering decision. So developers love building, right? So it's very hard for them to say that I want to pay for a piece of software. I think at the core, that still remains a problem where people and they are smart engineers, right? So technically speaking, they can build it. There is nothing that will, with the right set of people, with the right amount of time, they can always build it. But it is just expensive. There is also another aspect, I think, that is losing control. So it is, or at least the feeling of losing control, because as soon as you are buying a piece of software and saving the data in that system, you cannot go in and make arbitrary changes to the system. Actually, in the case of Skyflow, you cannot make any changes to the software. A lot of the parts are configurable that you can, of course, tune it to your needs, but you cannot go and make fundamental changes. I think engineers still are scared of what if I need this and the provider is does not agree, or sometimes engineers don't like opinions of a framework. They want to do it their own way. So I think it's a mix of all of these things, and it is just the cost. So that they are kind of overlooking.
Right. Yeah, and I think you touched on something important there, which is if you have the right people and the right engineers, you can probably build anything. But does it make sense for you to build it? You could presumably with the right team, you could build and recreate I don't know Salesforce, but does it make sense to roll your own CRM for your business versus just going and buying Salesforce out of the box or something like that? Like, I think it really comes down to does it make sense for your company to take on this challenge yourself versus like building whatever it is the product is that you essentially founded the company to, or whatever the problem is that you founded the company to solve.
Yes. So it doesn't make sense. So actually, there is one more reason. I am a car enthusiast, and I have seen actually people build their own cars. So, but they end up costing significantly more than if you would have bought the same car with the same specifications, or a car with the same specifications. And I have myself rebuilt part of my car, but that is a hobby. You We do that because it's interesting, because it's fun. But nobody will claim that it's the better use of time or money to do that.
Yeah, and is there a danger with even if you decide that you want to do this yourself for whatever the reason is, you don't want to give up control, or you think that for your particular use case it's not overly complicated. Do you see teams essentially running into an issue where they build a bespoke solution that then is not able to adapt to the changing requirements of either the privacy landscape or adapt to the changing requirements that the business might run into as it evolves and grows?
I think it will be very hard for somebody to build a flexible system which will keep adapting, which is able to adapt to all the needs. The privacy laws changes, the requirements changes, and also since it is not the core value for the other business, it will also you will have a hard time finding the right people, or you will not have the best people working on the project because that is not what is a customer facing feature. uh, so overall, I think it becomes really hard, and especially if it is not the core value proposition. Software engineers also try to take shortcuts and kind of get it done so that they can go back to customer facing features. which is a terrible place for privacy and security to do happen properly.
Yeah. Yeah. In a prior show, we talked about a similar issue with backups. A lot of times historically, you're not putting your top people on the backup solution because presumably you might never need it. It's kind of a, just in case. But of course, when you need it, you really want it to work. But a lot of times companies burn themselves by not actually having a proper backup solution that allows them to deal with the worst case and actually restore things, or even have a proper security around it because they kind of underestimated the value of putting their best people on that.
Mhm. And let's take that use case a little bit further, right? So when people start with a backup, they think that, hey, how difficult can it be, right? I'll just take the whole data, make a copy of it. There are enough cloud APIs that can be used to do the data sync, and we are done. And then people realize, oh, if the data starts growing, then how do we put it in hot storage and cold storage? And how do we do a diff and not do a whole copy of it? And they probably have not even thought about restore for a long time um, before they actually had an issue or somebody brought it up in a review that, hey, this part is not done. If you had to really restore it, it will take you um, X amount of time, which is not acceptable. So we don't even get the whole requirements if it is not the core business value.
Right. Yeah. It's very easy to underestimate the complexity of it if it's not sort of the core business case and it's not necessarily customer facing. So when it comes to actually building out a data privacy solution, whether that's someone building it themselves or maybe it is actually core to your business, like at Skyflow, how do you go about actually testing and evaluating the effectiveness of it?
Um, that's a mm, interesting question. So there are some core principles that you should always follow, which is to make sure that you are writing correct software. It doesn't, it becomes only more and more important when you're dealing with privacy and security. There are some things that have been established in the security domain, which we have to follow, which is to not be smart about encryption. So when there are standard algorithms, we have to use the standard algorithms. You cannot say that, hey, I'll make a small tweak and like you will always end up with at least one bug. So, and then when you're dealing with privacy, you have to, again, going back to zero trust, you have to implement it right. And you really have to focus on uh, what are the different ways data access can happen. And is there any way to go around the system? Is there any elevation of privileges that can happen? Is there any way that somebody can assume another identity and access somebody else's data? So zero trust principles becomes really important there.
So beyond just the testing and evaluating the effectiveness of a data privacy solution, if someone was building this themselves, or maybe we can even look at Skyflow, how do you remain up to date with all the evolving data privacy regulations and best practices that are going on?
So I think for Skyflow, it doesn't matter as much, or in terms of engineering, it doesn't matter as much because we we are building Skyflow with first principles, right? We security and privacy, we are doing that by design and not because some regulation said so. In other words, what does it means is that we are much ahead of what the compliance requirements are. Compliance requirements are a small subset of what we are building. So if the other way, if somebody is building kind of privacy solutions just to satisfy the compliance requirements, they will always be playing a catch-up game because every 2 years something more will become a required feature or a requirement, and it becomes incredibly hard to modify a system to meet new privacy regulations or security requirements. unless you design it from ground up, it becomes ends up becoming a patches on top of patches, and that is again not a good place for a privacy solution to be at.
Right. So essentially, the gist is, if you're building for compliance, you're always going to be behind because compliance is always going to be lagging behind really what is going on in the market in terms of security. It's a baseline, but it's not uh, the sort of be all end all of security if you're taking this seriously. So, in terms of looking at Skyflow, how do you ensure that Skyflow is resilient to cyber attacks and other security threats? So obviously we're not necessarily just doing the bare minimum around compliance, but the the world of cyber attacks, ransomware attacks, all these types of things is constantly evolving as well. So how do we stay ahead of the game there?
So the simple answer is listen to Daniel, right? So Daniel is our head of security. So if you listen to him, then you are almost safe. So that is true in many ways. We have a very thorough security review process where each new feature, each change goes through that process, and it is vetted not only by Daniel but also by the senior people on the in the company, that we are not missing out on anything and we are addressing all the threats that can originate. You have to follow all the security best practices that have been learned so far in the industry, which is to do like pen testing at a regular interval. You have to do all the patching, all the patches that come out in time. You have to be very strong in monitoring and the defense mechanisms so that if there is an incident, then it doesn't stay in the system long enough so that all the layers can be breached. So it's just a uh, uh, lot of layers, lot of different kinds of protection coming together to keep the data safe.
And would you say that to do this properly, it kind of has to be built in as part of the culture of the organization where, it's not a single person's responsibility, but it's essentially everybody's responsibility to be taking privacy and security seriously?
Absolutely, right. So it is easy for us because data privacy is kind of in the name of the company, not technically in the name, but that's the core tenet of what we are solving for. But if the core tenant is not privacy or security, it's very hard to get that culture. And without the culture and without that being a design principle, again, it becomes really patchy and when it's an afterthought. And that catch-up game never works out.
Do you see that as something that might be changing in the next 3 to 5 years with engineering organizations that are going to be more sort of keenly aware of the how serious they have to take these things and that it shouldn't be an afterthought and it needs to be something that's more baked into the culture of the organization?
Uh, I do think that uh, privacy will become more and more important. There will be a lot of engineers and organizations that are self-aware and they want to do the right thing. But at the same time, it almost will always clash the priorities within the company because unless, and that's why we talk about the Skyflow architecture or the data privacy vault architecture, which is to say that once you remove the sensitive data from your backend, your backend can scale up, can you can add a lot more value to your customers much more easily, and you can keep your focus there. Now, if everybody has to keep their focus on exactly how the data is getting used, it becomes overhead. And I think some people will do it. Actually, some companies have been doing it for a while, but that adds a lot of overhead to the entire process, and it means that you are adding a lot less. customer value than you can.
Right. So essentially, if you're taking this seriously and you're also taking on this challenge yourself using a variety of different tools and maybe something that you built yourself, it starts to become somewhat a barrier to innovation because that isn't necessarily your core business and you're not offloading that essentially to someone else. You're taking on that responsibility. So every time you build anything, you need to be thinking about, okay, well, how is this data stored? How is it processed? How are we, making sure that only the right people see it and so forth. So that sort of cost just gets added onto every single feature that you build.
And again, going back to the principle of isolation, I think anybody who wants to do it right will implement isolation. Without isolation, it's almost impossible to design it right or build it right. But also, isolation will be a very hard choice to make when you're building it internally because a lot of the stakeholders will not easily agree to it because that means that more and more hurdles for them and more dependency on this internal tool or internal mechanism that you're building.
So as we start to wrap up, are there any sort of future data privacy or security technologies that you're particularly excited about?
So I think there are interesting technologies that are coming up. One of the most interesting thing is the secure enclave. AWS has its version which is called AWS Nitro. It lets you have isolation in the known environment, which is the EC2 kind of stack they have. That does add some good protection, but also um, it's kind of interesting that it is isolated, so it's protected, but the way that they are providing the isolation, it is basically by limiting what you can do. So it also means that there will be a lot of things you cannot do, and you have to either get around it. And the moment you start opening up the system, you start losing the value of uh, the secure enclave. So there are other technologies many different kinds of encryption. I don't want to take specific names, but which where the performance is just not up to the mark to be usable in real life scenarios. So I do think that there will be other interesting technologies, but I am more interested in the architectures that can actually solve the problems. So data privacy vault being one of them. I would think that there might be other solutions which addresses some other aspects of data security or data privacy. Uh, but in terms of technology, uh, yeah, there are some I don't believe in, so there not much point talking about that.
Yeah, excellent. I think I do think Nitro Enclaves and the confidential computing or the sort of work that's going on in that area is really interesting. It does address some problems, not necessarily all problems. And for anybody that's interested in learning more about AWS Nitro Enclaves, we do have an episode where we spoke to the principal lead of Nitro Enclaves from AWS, and I'll include that in the show notes for anybody that's interested. But Roshmik, I want to thank you so much for being here and for taking us through all your thoughts around what it takes to actually engineer your own data privacy solution and what you should be thinking about as an organization of whether you want to take on that challenge. And if you do, essentially what kind of costs from an engineering perspective and maintenance costs that might be look like if you are actually going to do that. And vice versa, if you don't want to do that, then you should definitely check out Skyflow, skyflow.com.
Absolutely.
Awesome. All right. Thank you. Cheers.